Good morning, everyone. Everybody is in, and welcome to today's webinar, 3D Reality Reconstruction, Handheld LiDAR SLAM Scanning Solutions for Modeling Innovations. My name is Aura, your host, and actually speaking, I also the overseas marketing and promotion manager at Share. Thank you for joining us. And before we dive in, let me briefly introduce our company. And as you can see in the screen, Share is a global leader in cutting-edge 3D scanning technologies, especially in portable LiDAR solutions that redefine accuracy and efficiency across industry like construction, urban planning, and digital heritage. Today, we will showcase how our innovations empower professionals like you to capture reality in very details. And now, let me introduce today's speakers. First, we will have Simon, our field application engineer for 3D LiDAR SLAM solutions. Simon, just say hello to us.
Hello everyone, I'm glad to meet you here and I'm Simon from Share. Good evening or good morning.
Okay, thank you. So someone will deep dive into the technical process of our product, Share Slam S10, and then we will have Julie, our seasoned business development manager. And Julie, say hello to us.
Hello everyone, I'm Jolly. I'm the BD manager within Share. Thank you guys for attending the webinar.
Okay, thank you, Julie. Julie will share real-world case studies demonstrating the transformative power of our tools. Okay, let's get started. And next, Simon will unpack how the S10 combine portability, speed, and millimeter level accuracy to innovative 3D scanning solutions. Simon, the floor is yours. Please get started.
Okay. Hello, could you see the slide here? Yeah. If you made any question or you want to know something about the slides, just feel free to ask me on the comments and I will answer the question immediately. Okay, so let's get started. For my slides, I will give you a brief introduction of our product ShareSlam S10, and I'll give you some solutions about how it works. And let's get started. The first part is the production introduction, and the second part is the solutions. And for the first part, we will have the product overview first. On the right, the image is our S10. It's how it looks. As you all know, SLAM S10 is to be a handheld 3D data scanner. And one of its biggest features is it's handheld. That means it's light. The overweight is only 1 kilo. It's only 1 kilogram. And for its more details, it integrates the high pressure LiDAR to wide angle cameras and a RTK positioning module. Another feature of S10 is the laser and the images are deeply fused. That means some of you may have already know that our Share is famous for our cameras. So we use our own cameras and we use our own camera modules to make sure that all the images can work well with the data from the LiDAR. Here we have a more detailed images. And you can see here we have the RTK antenna, the LiDAR, and some of you may also notice the massive magnetic. That means when you are using an iPhone, you can get your iPhone to be connected with the devices and free one of your hand. That will save a lot of works. And don't miss the quick dismantle button that allows you to get the devices to be connected easily. And here we have the application fields. Today I'll show you two solutions on the facade measurement and graphic architectural design. But despite these two solutions, we also have reverse 3D modeling, cultural relic protection, and other applications, and on and on. The image is yours. And here is the advantages of our products. The first advantage I would like to show you is our LiDAR is installed at a tilt of 20 degrees to the ground. Yes, you can see on the picture that on the right, the degree is we have measured to make sure that it is the 20 degree. Some of you may be wondering why it's 20 degree. Okay, I'll show you how. First, let me explain our LiDAR. Our LiDAR is, we have used one of the most popular LiDAR that most of the handheld scanners have used. It has a wheel range field at 360 in horizontal and -7 degree to 52 degree in vertical. That means the wheel range field is fine. However, how to install this LiDAR to the devices can make a huge difference. There are two traditional ways to install the LiDAR. One is in vertical and another one is in horizontal. When you install it in vertical, that means the above, the in front of you, there is somewhere cannot be scanned so smoothly. So you need to frequent turning your position, turning your face to make sure that there are sufficient images and sufficient point cloud data. And another traditional installation way is in horizontal. That means the above, the ceilings, and the floor, the information from those two directions are really easy to be missed. So that give you some inconvenience when you're scanning. But if we install the LiDAR in the 20 degree to the ground, that means not only the ceiling but also the floor is covered, and the in front of you, the area is well covered too. So you don't need how to change your position. You don't need how to turn around to make sure that you have scanned every corner, because we have solved this problem on when we are designing our product. Another advantage is that our self-developed camera module, just as I said before, our share is famous for our camera modules. So we use our self-developed camera modules to make the full use of our advantages. There are three points I'd like to mention. One is of course, accuracy. Our camera modules make the time synchronization in microseconds. That means you can think the images that are taken from these two cameras could be at the exactly same time. So when you're processing these images to make our point cloud looks more like the true real world, then can give you a better coloring effect. And another point, the second point is the restoration degree. For our cameras, the effective pixels for per lens is 12 million. That means for two cameras, that's 24 million effective pixels. So you could get a really images that close to real life. And the third point is the field of view. You can see here the angle is 135. So for the horizontal, there would be 270 degrees, and in vertical that could cover 360 degrees. The third advantage is the absolute accuracy. Of course, we're using scanners to make a model of the real world, so we want it to be as exactly as accurate as possible. So of course, we have to mention our absolute accuracy. Like I said before, we have a integrated RTK module, and this RTK module could support full frequency from all the satellite system. That means even you're in a countryside, you're in a forest, or you're in somewhere just like not so close to the urban, you can always get the signals from satellites. And using the signals from satellites, we can use the positioning functions to make sure that the coordinate you get is exactly. The planar accuracy can reach 0.8 centimeter, and the elevation accuracy can reach 1.5 centimeter. And our RTK antenna is built in at the body position. That means no matter how you change your position, no matter how you deal with your scanner, the positioning is always the correct coordination. So the absolute accuracy can be ensured. And the last advantage I'd like to mention is our standard free software. Yes, you can get our software from our official website for free. That's an advantage I'd like to mention. Here are two images that have been processed by our software, and you can see the details from those two images, how this building looks like, how the tree looks like. You can tell every details from those images, and of course, that's our result of the cloud points that have been processed with our software. And our software is really easy to use. You could process all this data with just a few simple clicks. So here we have a simple conclusion. The advantages lies here: the LiDAR, the cameras, the RTK, and the software. And now I'd like to introduce you with the second part, the solutions. As I mentioned before, we're talking about the facade measuring and the plan and the plan drawing. And let's start with the facade measurement. One of the most common applications for the facade measurement is exterior renovation and protection of the building facades. As you all know, there are a lot of buildings that need to be renovation or need to be under protection. So we want to get the full details for images, for information from all these buildings, including the outside faces. So we need to do such measurement to make sure we got the data we need. So the aim is to quantify the materials required or to understand the external surface conditions. And an example is the renovation of all residential areas. There are a lot of old residential areas today now, so we could not just leave them like this. We couldn't leave them like the old, how they look like that old. So we need to renovation them. And here are the operations. For some details, the building in those residential areas are in average about 6 floors, and approximately they could reach 20 meters height. And key attention I'd like to mention is we need to get the entire elevation data. That means we need to make sure that the facade is being exactly scanned. So here are some tips for the operation. First is that we could have a horizontal distance of 10 meters from our target. For example, if there is a building you need to scan, you should have 10 meters from its entrance to make sure that our scanner could reach the top of the building. And second tips is that you should pay attention to the real-time point clouds on your phone apps to make sure that the point clouds on your apps have shown the full detail of the building, so that could make sure you don't miss the top. You are including the top of the building into your scanner data. And the third tip is that the tilt angle can be slightly adjusted if needed. That means sometimes the building is a little higher, or you just couldn't get the reach of the top. But don't worry, because our devices have installed IMU to make sure the position and how you're dealing with your scanners. So you could just slightly adjust the angle to make sure the top is being scanned. And for the data processing, here is a completed sketch. How could we get this sketch? First, just pre-process with our software SharePoint Cloud Studio, so that we could get a .less point cloud file. And then for this file, we need to input it into another post-processing software like Cloud Compare, like RealWorks, or something like that, to do the point cloud segmentation and to remove all those noises that we don't need, because we just want the point cloud of the building. And then we could yes, of course. I'll answer the question later. Let me finish my introduction of the processing first. And the third step is to draw the sketch on a drawing software, like CD or some drawing software. You just put the data from the second step into the software, and you just draw the lines from the edge, and you could get the sketch of this. And a point I'd like to mention is that you could use true color output or use the intensity information output, because all we need is the sketch, no matter whether it's in true color of the real world or no matter it's in the intensity information. We just want to get a clear look so that we could draw the sketch better. And yes, thank you for your precious questions. The Sure Slam S10 have a I'll show this on this screen. Does Sure Slam S10 have a moving object elimination algorithm? The answer is yes. When there is something moving in the view field, our algorithm will remove all those moving objects, like a moving car or some other people who might be shown in the scanner, or there could be some other thing that are moving. But our algorithm would remove all of this from the scanner, and the point cloud would not contain all those moving objects. Thank you for your questions, and let me continue with my slides. And the second solution is the architectural floor plan drawing. There are always sometimes we need to use the plan drawing for some reasons, but we could find the drawings are missing. So we need to restore the drawing. We need to get the drawing again. So involves the rational planning of the internal space of the building. We need to get that. And we need to come up with building safety regulation and functional requirements. That's something we need the plan drawing for. And for the operations, the operator with S10 just need to collect the indoor data of the building. And the graphic designer would complete the drawing using the data collected from the operator. And when you are using an S10, it only takes less than 10 minutes. Yes, less than 10 minutes from the very start up to the finish. And for if you're using other equipments like we do it in traditional, we may need some rulers or something like that. That would take for a 80 square meters building, it may take 2 hours or even much longer. And for the data processing, first, of course, using SharePoint Cloud Studio, of course, to get the .last point cloud file. And then we import that last data into some softwares like RealWorks or something that could show the planner profile. Just like the figure shown below, we could get the planner profile. And then we should import the profile into the drawing software like CAD and just join the line from the edge, and we got the plan views. And that's all I want to share with you. Thank you for your listening.
Okay, thank you, Simon. The S10 ability to capture complex environment in real time is truly impressive. For those who are curious about practical applications, stay tuned. Judy will share how customers utilize this technology. And then we will enter section 2. It is about case studies. Let's explore real-world success stories. Julie will walk us through 2 scenes, indoor management and service management. Julie, over to you.
Thanks, Aura. Hi, guys. So in my part, I will introduce the 2 application cases of SLAM S10. I will introduce how our users utilize the SLAM S10 in their real work to improve productivity for their jobs. And my sharing, we are including indoor measurement and facade measurement. Hope they can inspire on your applications. In the interior design industry, traditionally, we need 1 interior designer and 2 assistant designers to create floor plans in CAD. And the 2 assistant designers are responsible for measuring the rooms and providing the data to the designer. And the designer views the data and manually draws the floor plans. And so this industry really needs an efficient and high precision tool to complete the jobs. One of our clients, a construction company, they use Share S10 and the Recap, along with the software Recap and Auto CAD to provide their jobs a more convenient tool. Traditional methods, including tape measures, rangefinders, and manual record, are with low efficiency. They are time-consuming and labor-intensive, which requires high labor costs. At the meanwhile, they are very easy to make mistakes and some missing in data. When that happen, then on-site rework are required, as well as remeasurement jobs. So that is really annoying. Then S10 provides another solution. Let's see the efficiency comparison between traditional method with rangefinder and shares them as 10. In terms of field data collection, for 100 square meter house with rangefinder, it takes 1 hour for one people to do the measurement and extra time to sketch a floor plan. While for SLAM S10, for the same size of the house, it only takes one people 5 minutes to do the scanning and 10 minutes to process the data. And then through the auto CAD, we can generate CAD files. Regarding the data saving, as we know, the paper-based data is not easy to preserve, while last 3D point cloud data is available in any time. Therefore, in terms of data collection and data saving, ShareSLAM S10 really provides an efficient tool for the people. So, how can we to get a high quality endorsing data? Here we have some tips for you. First, large areas, then small areas. First, you can scan large rooms like the living rooms, leaving small rooms like the bathrooms for the last. First, long section, then short sections. After scanning the living room, follow the hallway to the end. Then scan the big rooms and the smaller rooms. Scan thoroughly to get details. When encountering details such as floor joints in the bathrooms, pipes on the ceilings, and the windows in the room, pause for 2 to 3 seconds while scanning to get more details. And then let's see the accuracy comparison. The upper images are the screenshots from the CAD file. And then the lower images are parts of the manual drawings from the designer. Here we have a more clear image comparison, data comparison. Here we have two groups of data from distance measurement with rangefinder and point cloud measurement. And as we can see, the difference between the two groups of data is within 9.1 millimeter. Let's say the relative accuracy of ShareSLAM S10 is within 1 centimeter. Therefore, the SLAM S10 provides both high precision and efficient solution for indoor measurement. Then let's go to the second part, facade measurement. In the residential design, renovation, and maintenance industry, building facade measurement is always an important part. By measuring the building facade, we can obtain information including the building size, shape, structure, etc. Facade measurement can effectively control the budget for outer wall plaster projects, avoiding unnecessary over-expenses. Typically, before the construction begins, the contractor entrusts a professional surveying team to perform surface measurement for the house and procure plaster materials based on the measurement data. And the professional surveying team that I just mentioned in the background, who in charge of the surface measurements, are the typical user for this industry. One of our clients, a surveying and mapping company, they utilize ShareSLAM S10 together with the software Trimble RealWorks and AutoCAD to provide an innovative solution for the renovation and maintenance industry, a new choice. Traditional methods, including total station measurement and the drone measurements, have their own sets of challenges. For the total station measurements, it takes a long time to operate, and the efficiency is quite low. Sometimes it's very tough to setting up in some scenarios, such as the narrow spaces, it's very tough to set up a total station. When it comes to data processing, data conversion is complicated and cumbersome, and it's very easy to make mistakes. For the drone measurement in urban settings, it always comes with the challenges of flight restrictions and airspace issues. This makes it very tough to ensure both the flight safety and the flight efficiency. Therefore, the drone measurements require high-skilled field personnel. When it comes to measuring low-rise buildings in the areas, the drones can't perform well because the clarity of the photos and the quality of the models can be quite lacking. Also, in the real works of facade renovation projects, especially for old burden communities, there are often situations where the houses are adjacent and the streets are narrow. The total stations and the drones can be operated well in the narrow spaces and cannot be used normally. Faced with above complex scenarios, the S10 can well solve the measurement problems in the low-rise buildings areas, providing the industry with a new choice. So here we have some operational advantage of SLAM S10 when it comes to facade measurement in the renovation industry. Compared with total station, the operation of SLAM S10 is quite easy. It don't have much requirement for the operators. The scanning speed is fast. For the similar projects of urban community facade measurements, when you are just walking, we can collect data. The data is very easy to get. The maps are easily and directly to get using CAD in the data processing. When compared with drones, similar to total station, the SLAM S10, the operation of SLAM S10 is quite easy. No need much requirements for the on-site people, and there is no time limited. You can scan the area for all day long. Also, no need for applied flight permissions and airspace, etc. Here we have a efficiency comparison between total station and sheer SLAM S10. Take an example of a 7-story old residential area and 6 units in one building. For the total station, it takes 2 people 6 hours to collect 4 surveys of a building. Also, the field personnel are required to identify details. They need to work together with the processing personnel. While for SLAM S10, that's another story. It takes 1 people 20 to 30 minutes to scan 4 surfaces. And the internal processing and the field personnel can work separately and independently. Therefore, SLAM S10 provides an efficient solution for facade measurement in this industry. So, how can we get a full facade surface? Firstly, about initialization, put the device on a flat platform and in a static position. Wait for the initialization for at least 20 seconds. About the scanning distance, ensure a proper scanning distance. Keep the horizontal distance to the target building's facade at a ratio of 1:1.5 relative to its height. That is to say, the height of the wall of the building should be roughly equals to 1.5 times of the scanning distance. If the environment doesn't allow the second point, then you can slightly tilt the device. And always check the mobile application SharePoint Cloud Studio to check if the foresaw data is complete. Adjust the scanner slowly and prevent abrupt movement. About operation time, we recommend you to scan in the dim light during morning and evening. Thank you for asking the question. Let me finish the tips part and then I will answer the question. Thank you. Okay. And the last tips is to finish the task. Wait for the task finish. Wait for the data is saved successfully. Then start the processing data. Can the result of S10 be integrated with L2 data? Yes, the result of the S10 can be integrated with the ground LiDAR data, such as L2. They have two kinds of situations, with RDK and without RDK. If the collected data has a fixed RDK, then it can support point cloud fusion on a third-party software based on absolute coordinates data. If without RDK data, you can use a third-party software to select and stitch future points as the common points to do the data fusion. Okay, then let's go to this. Regarding the accuracy of SLAM S10, here we have two groups of data. We compare the absolute coordinate data collected from Total Station and the SLAM S10. And from the result, we can see that the accuracy, the differences from the two groups of data are roughly within 5 centimeters. And as we know, the absolute accuracy of Total Station is within millimeter. That is to say, the shear SLAM S10, the absolute accuracy of shear SLAM S10 is within 5 centimeters. Therefore, SLAM S10 can provide an accurate and efficient solution for SAT measurement in the renovation industry. These are two cases that I want to share with you. If you have any insight for expanded applications of SLAM S10, please feel free to contact us. We will do more sharing in the future. Thank you.
Okay, thank you. Thank you, Julie. And next, we will enter the section of Q&A. Audience who curious about the question we promote can answer on the chat. And let me have the check on the box. Okay. For Julie, there is a question for you. Can the result of S10 be integrated with L2 data?
Thanks for asking. I just answered, but I can answer again, no problem. So there have two situations, without RDK and with RDK. Of course, we can support air and ground integration for the point cloud data. With a fixed RDK, the data can support point cloud fusion on a third-party software based on absolute coordinates data. When it comes to without RDK data, you can use a third-party software to select and stitch future points as the common points for the two data set.
Okay, thank you. Thank you for answer. And there is also a question for Simon. And can you see that? Is it possible to work in Italy or coordinate system?
Yes, thank you for your asking. And I'm sorry that up to currently is not able to work in ATRF 2000 Italian coordinate system, but we're planning to support the libraries from EPSG in the future, maybe a few months. This is in our plan, and you could rate the use of the ETRF 2000 Italian coordinate system very soon.
Okay, thank you for questions and thank you for Simon. And keep an eye in your box. We will email a recording and SLAM scan brochure to all audiences. If you miss some questions, our team will follow up personally. And a huge thank you for Simon, Julie, and all of you making the event success. Learn more about S10 or discuss solutions. You can contact me directly. And this is Aura. Have a good day. Signing off. Bye-bye.
Thank you.
Goodbye. Thank you. Thank you for your precious attendance.